Spain became champions of Europe, but was their young squad the secret to victory? At just 16, Lamine Yamal shined on the biggest stage. Meanwhile, experience didn't always deliver. So was there a relationship between squad age and squad performance in the Euro 2024 tournament? Well, let's see what the data tells us. The dataset we'll be using is this UEFA Euro 2024 database from Kaggle. So we can download it as a zip right here and then unzip it by clicking this. And then we can rename this to datasets. And then I have this folder on my desktop called Euro 2024 analysis. So this is where we're going to keep all our files. And now we can open up Visual Studio Code and open this folder, Euro 2024 analysis. And as you can see, we have all our data sets here. And we can create a new file called Euro 2024 analysis with the extension IPYNB, which is the Python notebook file extension. So this is where we're going to write all our code. And the first thing we can do to see if we've done everything correctly is to import the famous pandas library, which all data scientists love to use. Let's go to import pandas as PD and run it. So as you can see, it ran, and we've created our folder structure. Our file is here, and so now we can start the data preprocessing stage. So the first thing we can do is import our data, and we need the player playing time.csv data from these data sets. The rest we don't really need, so we can create our data frame called df and then use the function read CSV to read our CSV, and it's in the datasets folder. So we can do dataset slash player playing time.csv. Alright, now it will create our data frame automatically, and so we can see our data now. We have our player name, we have their position, their squad, their age, when they were born, MP, which looks like matches played, min, looks like minutes played, and some other stats that we don't really need. So the first thing I want to do actually is convert this min into minutes played, because it's kind of confusing. I don't know why it's called min. So we can do df.rename the columns that we'll be replacing is the min, and we'll be replacing it with minutes played. And we want to keep it in the same data frame, so we can do inplace equals true. Cool, and now let's check it out. So now we have minutes played instead of min, which is much better and easier to read. The next thing I want to do is change these NaN values to 0, because I think these players, it's not like they don't have a value. They just played 0 minutes. Like, unfortunately, Amir Abrashi didn't play. I guess he wasn't good enough.
He's going to have a pop. Oh, fantastic! Amir Abrashi with a sensational strike.
To convert these null values into 0, what we can do is set the minutes played column into using the function fill NA. So we can do minutes played dot fill NA, and this will fill the null values with a predetermined value, which in this case we want it to be 0. Okay, so let's check out our data frame now, and we can see it's updated to 0 instead of null, so that's very good. The next thing I want to do is, looking at the squad column, I just want to keep the this squad name, and I want to remove this abbreviation. So what I'll do is I'll set the squad column, and I'll perform some string operations on the squad column. So I'll be using the string accessor called str in order to be able to use a string function called split. So in this case, what the split function does, it will split the string into, depending on the parameter you give it, like the separator. In this case, the default separator, if you don't give it anything, is a space. So in this case, it will split it into 2 elements. So it will return an array of 2 elements, 2 strings, because well, there's only 1 space here, and in between that space is 2 elements. So in order to be able to, use that array, we need to use the string accessor again, and we want to basically get the second part, the second element in that array, because that will be the squad name. So in this case, it will be the first index. Okay, now let's check out the data frame, and we can see now the squad name is just the squad name without the abbreviation, which is what we want. Now the last thing I want to do is remove like all these unused columns that we will not be using for our analysis. So for the analysis, all I need is the player name, the squad, the age, and the amount of minutes they played. So we can do df is equal to df, and we can give it the array of columns we need. So in this case, I need player, I need squad, I need their age, and I need the amount of minutes they played. So these are the columns that I want. So we run this. Now let's check out our final data frame. And we can see, compared to this one, it's much cleaner because we don't need all this other excess data for our analysis. We just need these, so it's easier to read with. So I think that's it for the pre-processing stage for this data. It was quite simple, and now we can start our analysis. The first thing we can do to begin our analysis is get the average age per squad, since we are trying to find the relationship between a squad's age and the squad's performance. So what we can do is set a variable called average age per squad, and set it equal to our data frame, and then we're going to use the group by function, and we're going to group by the squad column since we want to get the average age per squad. And then we can still get the age column, and then apply the mean function to the age, and then just print it out per squad. And now we have the average ages per squad. So Albania's average age, Austria's, Belgium, and so on. Now, unfortunately, soccer is a competitive game, and only 11 players get to play on the field at any given time. Therefore, we can't just take a simple average of the entire squad's age. Instead, we use a weighted average, where the more minutes a player actually plays, the more they contribute to the squad's average age. This way, the squad's age reflects the players who are actually playing on the pitch and not just sitting on the bench. To calculate this weighted average age per squad, we can set a variable called weighted average age per squad, and then set it equal to, just like we have here, df dot group by the squad column, except now what we're going to do is apply our custom function, which we can use the lambda function in Python, since this is just a short function, so we don't need to define it in another cell block and then reference it. It's just easier to do it with a lambda since it's short. And our input is squad df, since this group by feature will return subset df's data frames for each squad. So that's our input. And now we can just calculate the formula. So we can do squad df of the age column, since we are looking for the average weighted age, and then multiplied by our weight. And in this case, our weight is going to be minutes played. Okay, and then just like in the formula, we need to take the sum of that and then divide it by our weight, which is minutes played. And then we also need to take the sum of that. And then we can run this, and it executes. So now let's print it out. So using this formula now, we can see Albania, for example, their average age decreased to 26.3. From here, it was 26.8. And that's because of players like Amir Abrashi, who played 0 minutes, but their age was quite high relative to other players in the squad. So using this formula, it won't take into account Amir Abrashi's age since he played 0 minutes. And using this formula, the 0 would cancel out right here, and it would not be included in the average age. So now these average ages reflect more players who actually played on the pitch rather than players who were on the roster but didn't really play. Now what I want to do is be able to visualize some of this data. So let's import a library called matplotlib.pyplot and as PLT so it's easier to reference. And we'll run this. So the first thing we can do is set our figure size. So plt.figure, and we can do fig size equals 30 width, 10 height, and then use this weighted average age per squad and plot it. So we want the bar chart. We can do the color equals sky blue, the edge color is black, and the width of the bars we can do 0.8. Next, let's add some titles. So we can do weighted average age per squad and font size 30. The X label can be the squad and font size also 30, and the Y label can be the weighted average age, and the font size also 30. And then we can do plt.tight layout to make it look better, plt.show, and let's check it out. So it doesn't look very clear because these labels are too small and these labels are rotated and too small as well, and looks like you're not really able to tell the differences between the age. So what we can do is set those X ticks, and we can rotate them so they look better and readable, and make them bigger. So we can do font size 20. The same thing with the Y ticks. We don't need to rotate them since they're easy to read, but we can increase the font size to 20 as well. And then we can, it looks like the lowest age here, minimum is like above 25 and the max is like 30, so we can set the Y limit to min 25 and max 30. Now we're able to see the difference in ages much more clearly between the squads. So looks like Ukraine's the youngest, Slovakia had the oldest squad, and the rest look like they're anywhere between 26 and 27 and a half years old, whereas Croatia, Germany, Slovakia, and Switzerland look like they are the oldest, and then like Turkey and Ukraine seem to be the youngest. So yeah, it's nice to look at these kind of charts to be able to visualize our data. So the next thing that I've done is I've created this Euro 2024 standings.csv file, And this was not included as part of the data set from Kaggle. And this just basically has the rankings of all the teams in the Euro. So, like Spain is obviously first, England is second because they were in the finals. Netherlands and France were third and fourth because they were in the semifinals. And you can see like Germany got 10 points because of their, they have 3 wins, so they had one more win than France. But their ranking was number 5 because they only got to the quarterfinals, whereas France got to the semis. So it wouldn't be fair to put Germany on top of France in terms of rankings because France got further into the tournament. So this is the rankings table, and I'm going to create another data frame called df2 and do pd.readcsv, and I'm going to just read this CSV called Euro 2024 standings.csv, and then we can just check it out. So these are just all the rankings like we saw earlier. Another thing is like Ukraine was lower than Denmark, so Denmark was 16th in rank, whereas Ukraine was 17th, even though Ukraine actually won a game, so they had more points. But because Denmark made it to the round of 16 and Ukraine didn't, it's not fair to rank Ukraine higher than Denmark. The next thing we need to do is we need to have a weighted average age per squad in this data frame table right here. So for each ranking, we need to have also a weighted average age per squad. And we have a data frame up here, which we created. So we just need to merge the two. So we can do df2 equals df2 dot merge. So df2 is this data frame right here, the rankings. And so that's going to be our left data frame. And our right data frame is going to be this one, the weighted average age per squad. So we can write that. And then we are going to join it based on this squad column right here. Since they both have these squad names, we can join it on the squad column from this left data frame. So we can do left on squad. And since we did a left on, our right index must be true, since we're going to use the indices from the weighted average age per squad data frame. And let's run this. So we get an error. Okay. I think this means that this data frame here, it doesn't have a name. We forgot to add a name to it. So we could just do this, dot name equals weighted average age. Execute that. Now let's check it out. Okay, so now it has a name, so it should work. So if we go back, let's run all. Okay, so now it works. So we can check it out now. df2. And there we go. Now for each squad, we have its ranking and we have its weighted average age. So for each squad, now we can compare the ranking versus the weighted average age for all the squads and see if we can find a common trend. To check if these two variables, rank and weighted average age, have a relationship, we're going to be using linear regression. And first, we're going to visualize these two variables on a chart to see if we can visually see a relationship. So we can import a library called Seaborn as SNS. And we can use a function called regplot, which is a regression plot, and have our x variable be the weighted average age, our y variable be the rank, and then add some titles and labels. So x label would be the weighted weighted average age. The Y label is the rank. The title can be just a simple title like weighted average age versus rank. And then we can do plt.show. So as you can see, it plots the regression plot, and we can customize this a little bit better. So for example, we can change the color of these points and the line. So to do this, we can do scatter KWS and then set the color as like blue, and then we can do the same with the line. We can set the color as red. And then I also want to remove this shaded area, which appears to be the confidence interval. So we can do CI equals none, because we don't want to see that. And then we can also add the figure size to make it fit better and display. So like we can do width as 15 and the height as 8. And we can also add a grid, so we're able to know where these points lie on the numbers. So the grid, we can do true, and then the line style, we can just do these 2 dashes. And also I want to label each of these points, because each of these points represents a squad. So we can label them. So we can do for I, comma row in df2 dot iterate rows. We can do plt dot text, and our x is the weighted average age, not per squad, weighted average age. And our y is the rank, and our string, what we want to see is the squad name. So we do squad. The font size can be 10, so that we're able to see it. And now we can run this. So now it looks much better. We have the regression line here. Each point has a squad name next to it, so we're able to see which point represents which squad. We have the rank on the y-axis, and we have the weighted average age on the x-axis. Visually looking at this chart, there seems to not really be any relationship between rank and weighted average age. The points seem to be all scattered in different areas, and there isn't really any significant pattern that we see. I mean, the regression line is somewhat increasing, but it's almost horizontal, so I don't really see any relationship between rank and weighted average age. I guess the only thing I notice is that the top 4 teams are somewhat all close to each other in the same block with these grids. But other than that, I don't really see any other relationship. So what we can do is, now we've seen it visually, now we can see the relationship mathematically. So to do this, we can import a library called scipy.stats. So scipy.stats, we can import a function called linear regression. And we can perform this linear regression using this function. So we can first run this. We can set our result equal to lean regress, and our x variable is the weighted average age. and our y variable is the rank. So let's run this, and now we can see what results gives us. So result will give us some values here. So the slope, the intercept for the regression line, our R value, the P value, standard error, and the intercept standard error. Looking at this R value, which is our correlation coefficient, it's very close to 0, it's 0.03, indicating a very weak relationship between our two variables, the weighted average age and the rank of a squad, which is what we saw in this chart, an almost non-existent relationship. Since all the points were scattered in different locations, we couldn't really see any trends. However, it's important to remember, correlation does not imply causation. Even if we had found a stronger correlation, that wouldn't mean age directly causes better or worse performance. Many other factors like player talent, coaching, squad value, team strategy are likely much more influential in determining a team's success. So now this gives you an opportunity to go in and try your own analysis, and you can go and analyze other factors that might affect a team's performance, such as the win-loss ratio, the goal difference of a squad, or any other variables that you would like, as long as you have access to the data set and you have the data. And it doesn't have to be the Euro 2024 tournament, it could be the World Cup, it could be the Premier League, whatever data that you have access to. And that concludes this analysis. Thank you for watching, and I strongly encourage you to go out there and try your own analysis.